So greetings from the land of cosine and sine. So I'm going to take a look at a few examples of how to graph functions that need to be transformed in some way. So I'm going to do a little graphing, and I'm going to walk through, just the way that I'm thinking through the problem as well. So to no further ado, let's begin. So graphing sines and cosines. The first one we have is a sine. And I know that that's significant because then I know that this graph will start at the origin. So it is a sine, and I'm going to start with the amplitude. So the amplitude for this particular problem, A, is equal to 3. That's that 3 right there. So A is equal to 3. And then next, let's take a look at the period. And the period has to do with that value right there that's in front of the theta. And the theta, or what's in front of the theta, is a 1. And so the period is not going to be changed at all. So you think about P for period is equal to 2 pi divided by B, and B happens to be a 1. So the period is unchanged. It's going to be 2 pi. So no transformation there. All right, so moving on to the phase shift. So the phase shift, in this case, it is sliding to the right, 5 pi over 6. So that is going to be a phase shift, okay? And then the K, well, that 2 right there is a vertical shift. It's moving the entire graph up 2. So this one is a vertical shift, and we'll say up 2. And I think that's all of the transformations that are going to happen. But there are quite a few transformations going on for sure. So let me go ahead and make some axes. Now, just for starters, these are not actually going to be the x and y axis, but I'll call them the virtual x and y axis, because what I'm going to do is I'm going to use those transformations to make a virtual y-axis and a virtual x-axis, so to speak. So as I go through this problem, I think I'm going to start with the 2 and say that y equals 2 is how high that midline is. The midline is 2. And then I go to the other side, the amplitude. So let me go ahead and do the amplitude as well. 2, 3. So the amplitude is 3. So 2, 3, 4, 5. So it's going to go up to 5. And then it's going to go down to 2 minus 3 is a negative 1. All right. So we have the vertical shift, and we also have our amplitude kind of set. How high and how low goes up to 5, and it goes down to a negative 1. So let me go ahead and mark my hash marks now. So I know that there is going to be no change whatsoever, but this has been shifted to the right. It's been shifted to the right 5 pi over 6. So I'm just going to say that that hash mark right here, it's like my virtual y-axis. My virtual starting point for my sine is going to be right there. That's like my virtual origin. And so what I'm going to do is start moving or labeling all of these hash marks. And if there's no difference or no change at all, then if I go to my period and think about it like this, 2, 3, and 4. I always go 4 hash marks to get to the full period. So I know that the period is 2 pi. Half of 2 pi is 1 pi. Half a pi is pi over 2. And so I know that every hash mark is going to be adding another pi over 2. So this one will be 3 pi over 2. And that's if we start at 0. It would go 0, pi over 2, pi, 3 pi over 2, and 2 pi. However, this one is not starting at 0, but is starting at a positive 5 pi over 6. So what I'm going to do instead is start at 5 pi over 6 and just continually add a pi over 2 to that. 5 pi over 6 plus pi over 2 is going to be equal to a 4 pi over 3. So this is going to be 4 pi over 3. Okay, so adding a pi over 2 each time is going to give us hash marks of 4 pi over 3, 11 pi over 6, 7 pi over 6, and 17 pi over 6. Okay, so I know that we're going to start here at 5 pi over 6. And so I'm going to start and go up to a maximum and go back down through at 11 pi over 6. And like so. There we go. And then I'll put arrows indicating that this is going to continue in each direction infinitely. And so the first one is done. Some of these are going to be really tricky. So you might want to follow along and make sure that you are taking good notes so that you can kind of stay engaged and keep active. Okay, second problem. Y is equal to 10 cosine theta minus 2. So I'm going to just start by writing down all the different parts. So the amplitude first, A is equal to 10. Period. It looks like the period, there's also no change at all. So the period P is equal to 2 pi over 1. So once again, the B is equal to 1. So the period again is 2 pi. And of course, what that means is that the fourth hash mark is the period. Half of that is pi. Half of that is pi over 2. And then 1 pi over 2, 2 pi over 2 reduces to pi. 3 pi over 2. And then 4 pi over 2 is going to reduce to 2 pi. So that's what my hash marks are going to look like. So between every hash mark is going to be a pi over 2. How about a phase shift? Well, this one is nice because the phase shift is actually none. So I don't see anything inside the parenthesis moving left or right or whatever. So the phase shift is none. The vertical shift, well, there is a vertical shift, and it looks like the vertical shift is going to be down 2. All right, so in this case, I do have a y-axis right there. That's not going to move. That's going to still be my starting place. However, this A, or the midline, is y equals a negative 2. So y equals a negative 2. So what I like to do sometimes is just forget about the x and the y axis for starters. And maybe if I remember, I can put those x and y axes back in later. I think I'll do that this time. And 1, 2, 3, and 4. 1, 2, 3, and 4. So I know that there's no change in the period, and there's also no phase shift or no horizontal translation. So that means that every single one of these hash marks is going to be labeled like so. 3 pi over 2 going backwards, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay, starting point for sine would be at the origin, but this one happens to be a cosine. So it's going to start up here at its maximum. So that's its starting point. What is that value though? If we started at negative 2 and we're adding a 10 to that, then this goes up to 8. Right? Negative 2 plus 10 is 8. When I do a negative 2 and I subtract 10, it goes all the way down to a negative 12. So that's going to be, the high is going to be at a maximum of 8. The minimum, the low, is going to be at a min of minus 12. So we're starting here. And I'm going to just go back and forth. I know the pattern for cosine. And so on. There it is. Okay, so the cosine. So y equals 10 cosine theta minus 2. So y equals 10 cosine of theta minus 2. And let me see. Let's put an x-axis. It would be right about there. That's the x-axis. And then the y-axis is going to be unchanged. Y-axis will be right there. And that one is finished. So now we're moving on to the next. And they just continually get harder. This is going to be the hardest of them all, I believe. So this is y is equal to 5 sine of a negative 3 theta and a minus 2 inside the parenthesis, and then a plus 5. So if we start with amplitude, the amplitude A is equal to 5. It goes up 5 and down 5, period. Well, let's see what the period will be. So there's going to be a change because that B value is equal to 3. I'm going to ignore the negative right now and just say that B will have to be positive. And so to find the period, P is equal to 2 pi over B. And that B is going to be a 3. So it looks like that's completely simplified. So the entire period is going to be 2 pi over 3. So if we go 1, 2, 3, and 4, the fourth one will be my period, 2 pi over 3. And then I'm going to half that to find the middle point. Half of 2 pi over 3 will be a pi over 3, right? It makes sense. Half of 2 is 1. Half of 2 pi over 3 is 1 pi over 3. And then if I half that, well, I'm going to have to double the denominator to get pi over 6. So that tells me that every single hash mark, you're adding a pi over 6 each time. So pi over 6, pi over 3. And what's that going to be if I add pi over 3 to pi over 6? What am I going to get? I think that's a pi over 2. And then a 2 pi over 3. So that would be a 0. And then if I go negative, that would be a negative pi over 6, and so on. So every hash mark is worth a pi over 6, either direction. All right, so that's the period. Now, what about a phase shift? Well, in order to find the phase shift, I think I'm going to have to do a little bit more work. Okay, so up here, I have the equation y is equal to 5, and this is a sine, so that tells me its starting point. But I'm going to do a little factoring technique just to change the value, or just to change the format. I'm not changing the value of anything. So I'm going to factor out a -3. So when I factor out or divide out a -3, I get theta. And that's a negative and a negative will become a positive. And the way I divide a 3 out of pi over 2 is I multiply by 3 in the denominator, and that becomes plus a pi over 6. And then it goes plus 5. Okay, so my phase shift, now I can see it. Now that I might have thought the phase shift was actually pi over 2. And that would mean pi over 2 to the right. But hold on a second. After I factor out the -3, now I get a pi over 6. And this one's going to the left. So I'm just going to say that my phase shift is left pi over 6. And then that leaves me with the vertical shift. And it looks like the vertical shift is just that 5 right there. It's just up 5. And I think I am ready to go. Let's see. Still have a lot more to go with this question, though. Let me start by writing out. This is a y is equal to 5. So I like to start with the vertical shift. So y is equal to 5. That's how high it goes. And then I'll go to the front where there's a 5. And I'll say, well, I know that if it starts on the midline at 5, and we're going to go up 5, then that's going to be a 10. And then 5 minus 5 gives me a 0 down here. Well, 0 tells me that's going to be the x-axis down at the very bottom. Okay, that's the x-axis. All right, so that takes care of the plus 5 and the amplitude of 5. Now, how about the pi over 6 to the left? This line, this vertical line then, is going to be a negative pi over 6. And I think we already determined before that when we found out the period was 2 pi over 3, and we halved it and then halved it again, and found that, well, between each hash mark is a pi over 6. So I'm actually starting at pi over 6 to the left. And what I'm going to do is add a pi over 6 each time. Okay, well, what that means is I add a pi over 6 to a negative pi over 6, and I get a 0. And 0 plus pi over 6 gives me, for this hash mark, pi over 6. And pi over 6 plus another pi over 6 is 2 pi over 6, or maybe we'll call that a pi over 3 to reduce it. So 2 pi over 6, and then we'll add another pi over 6 to get 3 pi over 6, and I'll reduce that to pi over 2. All right. So we decided this is a sine, and so I know that it's going to start at that virtual origin right there. So we've gotten this started, but there's one really important detail that I haven't mentioned yet, and it's an important one, and it has to do with that negative right there. What does that negative do? Well, that negative is going to be a reflection, and it's going to be a reflection over the y-axis, or a y-axis reflection. And so now we have to be really careful, though. Y-axis reflection, you think that means it's going to reflect over the y-axis, and the y-axis is actually going to be right here. But hold on a second, because of this phase shift, horizontal translation, it's kind of like the y-axis has shifted to the left. So there's a virtual y-axis at negative pi over 6. And so I think what we're going to do is reflect it over that line rather than the y-axis. So it's the virtual y-axis at negative pi over 6. So let me go ahead and start dotting in what this is going to look like before we do a reflection. Remember that negative right there is reflecting over, so like a horizontal direction, but reflecting over like the y-axis. Happens to be a new y-axis, however. So I'm going to start here and just start dotting a sine. Here's what my sine is going to look like. Okay. It's going to look something like this. And maybe I'll go a few more points to the left. Negative pi over 3 and negative pi over 2. I always want to have at least one complete revolution. And so it's going to go down and back up again, just like that. Okay, so I've dotted it just to help to realize that that's not the final answer. I'm going to put the final answer in red next time. Put it in red. All right. So now what does this look like if I reflect across this virtual y-axis? What is that going to look like? You know, if I flip it, or I could use this as a fold line. Like if I fold it over this line, then what is my graph going to look like? Well, to me, it's going to look kind of like this. I'll dot it first, but it's going to go across that axis, that virtual y-axis, and it's going to look like this. Just like so. And now I'm feeling like what I want to do is make that solid, because that is going to be my final answer. Let me say this: y is equal to 5 sine of negative 3 theta plus pi over 6 and then plus 5. That's that graph right there in red. Theta looks like a blob, but that's supposed to be a theta. A little too much ink coming out of this pen. And then I'm going to finish off by in green putting my x and y axis, like the actual x and y axis. So there's my x-axis. And then my y-axis is right there, supposed to go through that point. And that's the actual y-axis. So it looks like this. And there's my sine function. Okay. So that one is completely finished. That was a doozy. If you think back to all the different parts, you know, if on the amplitude, had to find a change in the period to be 2 pi over 3. And we had a phase shift to the left, pi over 6. That moved everything to the left. Had a vertical shift up 5, moved everything up 5. And then finally, the reflection over the y-axis, where the y-axis is actually shifted, which makes this problem very, very complicated. And so I am going to now move on from this question and go on to the final one. Okay, last question looks like this. Okay, so y is equal to cosine. We have cosine this time of theta over 4 plus pi over 4 and a minus 2. I think the first thing I'm going to do, seems like I'm always going in a different order with how I solve these, but first thing I'm going to do is do a little factoring technique. If I do the factoring technique, then I can more easily see the phase shift. So I'm going to say that y is equal to cosine of, and I'm going to say theta over 4 is what I'm going to factor out. Factor out a theta over 4. And let's make that a 1 over 4. I did that incorrectly. Going to factor out a 1 over 4. And so that's going to leave me with theta by itself. And plus, when I factor out the theta over 4, it's just going to leave me pi. And then I have also a minus 2. That's it. Okay, so that's going to be my phase shift. Phase shift is plus pi, so that's going to be pi to the left, and then vertical shift down 2. So let's go through the different parts. So amplitude A is equal to 1. Goes up 1 and down 1. Period. Well, we are going to have to do a little bit of work. The period P is equal to 2 pi over 1/4. Well, this is one of those situations where I'm dividing by a fraction. So what I want to do is invert and multiply. So that gives me a 2 pi over 1 times 4 over 1. And that gives me a grand total of 8 pi. So my period must be 8 pi. So let's think about that quickly. 1, 2, 3, and 4. So the fourth one is going to be 8 pi. Half of that is 4 pi. Half of that is 2 pi. So every single hash mark is adding another 2 pi. So 2 plus 2 is 4. 4 plus 2 is 6 pi. And 2, 4, 6, 8. 2 pi, 4 pi, 6 pi, 8 pi. So that's going to be the layout for my hash marks when I'm ready to do the hash marks. Now let's look at the phase shift. And the phase shift is a plus pi. Plus pi means that it's going to the left pi radians. The minus 2 for the vertical shift means down 2. Down 2. Okay. I think we're ready. And let's start by labeling. Let's see. Let's label the minus 2. So y equals a minus 2. So I know that it's going down 2 to start with. And also, I know that it's going pi to the left. So that means that this virtual y-axis is actually a negative pi. So negative pi. And we already decided that every hash mark was going to be adding 2 pi to the previous one. So if I start here at negative 2 pi, or I'm sorry, that's negative pi, and I add 2 pi minus pi gives me pi radians here. And then pi plus 2 pi gives me 3 pi radians. Plus 2 pi, it's 5 pi radians. And then plus 2 pi is 7 pi radians. Okay. So that's all of my hash marks. And what's next? Let's go to the left a little bit as well. Negative pi and minus 2 pi is negative 3 pi. Negative 3 pi. Negative 5 pi. Negative 7 pi. All right, so this is a cosine. So I know on my virtual y-axis that it's going to start right there at the maximum. And let's figure out what that maximum is going to be. Because I have a negative 2, my amplitude is only 1. So this is going up to a negative 1. Only up to a negative 1. And negative 2 minus 1, it goes down to a negative 3. So it's going up to negative 1 and down to negative 3 because my midline is at negative 2. All right. Just like that. And like that. Okay, probably be a good idea for me to dot those because those aren't actually the axes. Let me put the actual X and Y axis in now. The X axis is actually going to be up here. So it's going to be up there at 0. The Y axis is going to be right between these two. The actual Y axis is going to be between those two. So just for reference, it's a good idea for me to put in the X and the Y axis, and I believe that that's it. So that's a wrap. I hope that made sense. I know that it's quite complex, but I'm hoping that we will be able to take this, maybe review it if you have to, and hopefully that was helpful. Thank you, and bye-bye now.